In the previous video, we were discussing about the three basic differentiation formulas. Now we are going to discuss about a new concept. So this concept here, we will be having a product of two polynomials or a product of a term and a polynomial or product of two algebraic terms. Okay, we are going to differentiate in this case. So whenever we are having differentiation in this case, okay, we will be having the first polynomial or the first term as it is. We'll have that polynomial as it is and we'll differentiate the next polynomial, that is g of x. So if we differentiate g of x, that is going to be g dash of x. Then add it, always it's going to be addition. So now we have differentiated one of the two polynomials, right? So now what we are going to do is we will have the next polynomial, that is g of x as it is, and we are going to differentiate the first polynomial, that is f dash of x. So what happens here is the product of two polynomials, one polynomial is kept as it is and the other one is differentiated in both the cases. So this is going to be the differentiation whenever we are going to have product of two polynomials or two terms. So this rule will be called as product rule under differentiation. So let us discuss a problem in this concept. So now we'll discuss an example problem. F of x is equal to x cube plus 7x minus 1. G of x is 5x plus 2. We are going to differentiate f of x into g of x. These type of problems where both the polynomials are algebraic polynomials. Okay, in that case we can multiply both f of x and g of x and then also you can differentiate. But it is not possible in all the cases. Every time we cannot sit and waste the time by multiplying and then differentiating. So that is why we get into the concept of product rule in differentiation. That is, we differentiate side by side without multiplying the two polynomials. But even if you multiply and then differentiate, that will also be right. That's not going to be a problem. So now let us find out d by dx of f of x into g of x. So as the concept goes, the concept will be, we'll have the first polynomial f of x as it is. We'll differentiate the second polynomial. We'll add it with the second polynomial as it is, differentiate the first polynomial. That's it. So f of x into g dash of x plus g of x into f dash of x. So let's do that here. So now here f of x is x cube plus 7x minus 1. Multiply it with g dash of x. Now we are going to differentiate g of x. Okay. So this is a binomial. We are having two terms. Let's differentiate the terms one by one. Look at the first term here. This is 5x actually. Okay. So let's have 5x. We are going to differentiate 5x now. We are having a constant term, that is we are having a number and we are having an algebraic term. So the number we will be having it as it is. So let's have 5. Now we are going to differentiate the variable term. So the power of this variable x is 1 here. So nx power n minus 1 concept. So this will be 1 into x power 1 minus 1. That is, when we have x power n, if we differentiate, it will be nx power n minus 1. That is, d by dx of x power n will be nx power n minus 1. So here the power is 1. So 1 into x power 1 minus 1. That only we have written here. Plus, we have the next term 2. What is the differentiation of a constant term? D by dx of a constant term is 0. So we'll have it as it is. Okay. Then now we're going to the next term now. G of x as it is. So 5x plus 2. Let's have it as it is. Now we are going to differentiate f of x. So now we are having x cube plus 7x minus 1. Let's differentiate it. We have x cube now. X cube in this pattern, nx power n minus 1. Here the power of the variable x is 3 children. So this will be 3x power 3 minus 1. See, nx power n minus 1, 3x power 3 minus 1. That's it. We have differentiated the first term. Now let's differentiate the second term. Second term here it is 7x. So when we had 5x, what did we do? We kept 5 as it is and we differentiated x. Same concept here also. We'll have 7 as it is and we'll differentiate x now. The power of x it is 1. So this is going to be 1 into x power 1 minus 1. That's it. Now we are having a constant term. D by dx of a constant term is 0. So minus 0 or plus 0 all are same. Now let's simplify. This will be x cube plus 7x minus 1, the polynomial as it is, into 5. 1 into x is x again. X power 1 minus 1, x power 0. X power 0 is 1, but once we will write this step. X power 0 we will have plus 0, so let's omit it. Plus 5x plus 2 as it is. Then here followed by 3x power 3 minus 1, that's going to be 2, plus 7 into 1 is 7. X power 1 minus 1, that is going to be x power 0. Minus 0, let's omit it. So this will be x cube plus 7x minus 1. X power 0 is 1 children. So 5 into 1, 5. Plus 5x plus 2, the polynomial as it is. 3x square plus 7 into x power 0, that is 7 into 1. So this is 7 here, since x power 0 is equal to 1. Okay, now let's multiply and expand it. That's it. So each term of this polynomial should be multiplied with 5. X cube into 5, 5x cube. 7x into 5, that is 7 into 5, 35, and x minus 1 into 5, minus 5. Plus, let's multiply here each term of this polynomial with each term of the next polynomial. 5x into 3x square. Let's multiply 5 into 3, 15. X into x square, x cube. Next, 5x into 7. 5 into 7, 35. The variable x as it is. So now we have multiplied 5x with these two terms. Next, 2 with 3x square. 2 into 3, 6x square. 2 into 7, 14. That's it. Now let's group the like terms and we'll add 5x cube, 15x cube. That's going to be 20x cube. 35x plus 35x, 70x minus 5 plus 14, that is plus 9, different sign. So we have subtracted and we have given the greater number sign. Plus 6x square. Let's arrange it in the standard form, children. This is 20x cube plus 6x square plus 70x plus 9. That's it. So we have differentiated the polynomial f of x into g of x. That is, the product of the two polynomials is being differentiated directly. That's it. Thank you.